This video will explain to new students what a circuit board is and how a circuit board gets designed. Here is a typical circuit board. It has a combination of through-hole devices where a pin goes directly through a hole and gets soldered to a plated hole. This is a surface mount device where the pin actually lays on a surface mount pad with no holes. Then it gets soldered, and then in order to make the connection, comes out to a via and then goes to the rest of the board. Another thing the circuit board will have is reference designators. Notice that this particular package is called an R34. These are Zener diodes, ZD. This is a regular diode. These reference designators are very useful to the engineer when they go to debug the board. The designer's job is to create the pad stacks, create the packages, keep the library up to date, and also place the board and route the board and create the artwork. You'll always have a library of parts. Sometimes you'll have a library of pad stacks. Sometimes you'll have a library of actual surface mount parts and through-hole parts. In this case, let's edit one of these pad stacks. If we open it up, we see it has lots of data in it. It'll give you the drill size. You can put whatever drill you need. As far as the design layers, it'll tell you the end layer pad size, as well as flashes and anti-pads, and it'll give you lots of data. It'll give you mask layers. Now the mask layer, that is the green part of the circuit board. That is what prevents the solder from flowing and making shorts. And the program will always give you all the data on the pad that you have created, and that way there you have a good snapshot of what's going on. Now this is a through-hole part. If we wanted to look at a surface mount pad, we'll just open one of these. Now this only is on the top layer. Notice there's no hole that goes through the board, and it's just what they call an SMD pad. There's no drill symbol, but in the design layers you'll only have the begin layer because it's only on the top, and it will have a mask layer because that's very important. And again, you have a summary that you can take a look at, and we see that it's just a rectangle pad and it's only on the top. After you create all the pad stacks you need, let's take a look at a part. This is an example of a DIP 14. And notice that we have the pad stacks that we might have created or might have gotten from a library. This little center hole would be a drill. The outer ring would be your copper, and this other ring would be your solder mask. So the solder mask would go through this and prevent any shorts going from pin to pin. And this is an example of a surface mount device that you might create. And notice that the pads are only on the top layer. And this denotes the body. This denotes the reference designator. This would be the silkscreen reference designator. This would be the assembly drawing reference designator. And the dev type might be put on. Sometimes they put them on, sometimes they don't. All depends what company you work for. And probably the most time-consuming thing in circuit board design is routing all the routes. We see here that we have one route that is not routed. Let's route it and we'll show you how that's done. So right now we have a lot of things turned on, and what I'm going to do now is open up the visibility tab, and I'm going to turn off the top and I'm going to turn off the bottom. And the reason I do that is I'm only interested in these two layers. And if we move over to this area here, I'm going to start my route with this. And we do that by going over to the Add Connect icon, and now we can start to route. And what I'm going to do is I'm going to bring this down. Notice that we have the layers are some layers are typically going up and down, and some layers are going to the side. Now, in order for me to get to that pin, my via has to be up to about here. So I'm going to double click it, and I'm going to finish the connection. Boom. So that's it. That completes the connection. Now if we zoom in a little bit, I'm going to zoom in right to here. Oops. Say oops. We even have an oops button. Notice we have just a little bit of a little ding here. What we're doing now is I can go to slide. See, this is the slide. And what I'm going to do is I'm going to just do this and maybe just get away from that area a little bit. That'll make the signals a little quieter. So now we know what a pad stack is, we know what a surface mount component is, we know what a through-hole component is. Let's get to work and start creating some pad stacks.